6.6a is rational exponents. When you see rational, it's talking about fractions. So what that means is you're going to have fractions in the exponents, and it's not super hard, especially if you've been following along the last couple of days, because rational exponents are going to be the same thing as the radicals that we've been doing. So we've been doing radicals for the last 3 or 4 days. It's basically the same thing, you just have to get there. So when we've looked at a square root, okay, remember a square root, you don't have to write a little 2 there, but it's a little 2. And so when you have a square root, you have a second root, but that's like a fractional exponent. We don't usually have to deal with fractions, but that square root is like taking 5 to the 1/2 power. 5 to the 1/2 power is the same thing as the square root of 5. So what we have then in this problem is 5 to the 1/2 to the 5th power. Okay, 5 to the 1/2 to the 5th power. All you need to do here, think about what you've done in the past when you've had a number with parentheses separating another number. Number parentheses number generally means multiply. You're going to multiply those two things. And if you multiply those two things, this is just a numerator. The 5 is the numerator. You multiply by the numerator, not the denominator. It's like 5 over 1. If you're going to multiply that, you're going to get 5 over 2. 5 over 2 is the exponent. You have 5, your big 5, with a 5 over 2 exponent. Rational exponents means fractional exponents. 5 to the 5/2. So then number 3 is an easy problem because they don't have that extra exponent. You've got a square root. A square root is just a 1/2 power. M to the 1/2. That says square root of m. Same thing. So, you know, if I made it, let's make it more complicated because I see a problem over there. Let me give you another example. All right. So another example. Let's say you have the 3rd root of 4 x, and we're going to square that. Okay, so that looks like kind of like problem number 4. Let's do this extra example so you'll know how to do one more like number 4. Okay, well this little root right here is the denominator of your fraction. It's 1/3. That is a 1/3. And so you would have the 4x right here is going to be to the 1/3 power. 4x to the 1/3 power. And that 4x to the 1/3 power is getting squared. So the whole thing is getting squared. The 1/3 power is getting squared. Now, again, think about, you know, way back to 6th grade math or something, when you had two numbers separated by parentheses that told you to multiply them. That's what we're going to do here. We're going to multiply those two things. That 2 is like 2 over 1. So 1/3 times 2 over 1 is 2/3. So we'd have 4x to the 2/3 power. 4x to the 2/3 power. Okay. Now, sometimes there are some extra things we're going to have to break down, which is going to get kind of confusing, but that's a start. Notice I didn't read the directions in that problem, but write the expression in exponential form. Exponential form, we want exponents. Radical form, we want radicals. Okay. So now let's simplify. Let's simplify. Now, to me, it's harder to simplify in rational form. So I might like it back in radical form. That's what we've been doing the last couple of days. Fellas, stay with me. So knowing what we just learned, this denominator right here is the root index. Okay, so we should be able to go backwards and understand that this is going to be a square root. That denominator tells me that this is a square root. Okay? So it's a square root of whatever that was, 4x squared. Square root of 4x squared. Well, that looks like the problems we've been doing for the last several days. We should be able to do the square root of 4x squared. Okay? Question? Well, I haven't put the 3 on there. But the 3, think back to what we did in the last couple of problems. The 3 was going to be an exponent. Okay? So the 3 was going to be an exponent. And so we'll handle that at the end. So good question. Now, square root, remember, we don't really need that 2 there. So that's still a square root, and we do a square root like we've done before. Well, we know the square root of 4. The square root of 4 is 2, and then the square root of x squared, remember, there was a 2 here. 2 goes into 2 one time with nothing left over. So this is the same thing we've been doing for the last couple of days, but don't forget about that 3. Okay? So if I want to simplify, generally when it says simplify, it means get rid of like terms, get rid of parentheses if you can, simplify. I can simplify this, okay? Because I've got 2x to the third power. I've got 2 to the third x to the third. Both of those numbers are taken to the third power. 2 to the third x to the third. Well, 2 to the third power is 8. I've got 8x to the third. Simplified. Okay? And that looks a lot more simple than what we started with for sure. Okay? So in order to simplify this, I had to do what I'm about to do in number 7. So number 7 walks it back and is a little bit easier problem. Write each expression in radical form. Radical form, I want the radical. And for radical form, remember this denominator? The denominator is the root index. And so that denominator tells me that I'm going to have a third root. Real quick, I know I'm going to have a third root. A third root of what? Well, look at what's left. You've got b. And at this point, there's really 2 different ways you could write it. You could write the third root of b to the 4th, or you could write the third root of b to the 4th. Those both say the same thing. Those both say the exact same thing. Okay, it's just a matter of taste, I guess, or which one do you think is a better way of writing it? I kind of prefer this way. Third root of b to the 4th. Okay, so let's look at number 9. Do you have a question? Well, you're right. You could. All right, that's a great point. Because what we did last week was we said 3 goes into 4 one time with 1 left over. That's true. Okay, that's true. I guess the reason that I didn't do that is because it didn't say simplify. It just said write in radical form. But what you did was you wrote it in radical form and then simplified. So that's very good. That's very good. Okay. As far as writing it, I would have to accept this, I think, because this is in radical form. But I like your way better. Yes. I would take either one of those. I think you could stop right here if you wanted to. Yeah, write it in radical form. It's like think about way back if you had to convert a decimal to a fraction. If I said 0.5, I want that as a fraction. You're going to say 1/2. But if he said 2/4, technically that'd be right as well, right? It's just one of them's more reduced than the other. It's kind of the same idea. Good questions. Keep them coming. So we're writing radical form, all right? So remember, the denominator is the root index. Denominator is the root index. So we know there's going to be a 6th root of something. So that 6th root, to me, it looks like the sixth root of 10b to the seventh, okay? That's kind of what it looks like, okay? Or if you were going to simplify that, you would call that the sixth root of 10 to the seventh b to the seventh. So both of those things are to the seventh power. If we want to simplify, we'd say 6 goes into 7 one time with 1 left over. And likewise for the b, 6 goes into 7 one time with 1 left over. So that's probably the best answer. But as far as answering the question, writing in radical form, this would also work. Radical form. Radical form has a radical. Exponential form has exponents. So number 11, write in exponential form. Write in exponential form. This is a root index of 2. It's a square root, so it's a root index of 2. So all we have to do is say this thing to the 1/2 power. Remember, the root index is the denominator of the fraction. The root index is the denominator of the fraction. So number 12 looks a little bit more complicated. So let me spice it up a little bit. So if I said the square root of 2m to the third, let's say, okay, you've still got that root index. So you've still got a 2m, and you've got that denominator 2. The only difference here is now you've got a numerator. You've got this power, which is going to go right there. Okay, so that's kind of a different problem. Don't get that confused with problem number 11. 11 was this, and then you've got this extra problem. Okay, so number 13. As is, it's just 6n to the what power? 1/3. Exactly. And that's it. That's it. Okay, that's all you do. Now, do I need parentheses there? Would it still be right if I did not put parentheses? No, why not? Right, because the only thing this 1/3 goes to is the n, but I need the 1/3 to go to both. Okay, so how do I show that it goes to both? Well, that's why I have to put parentheses in. Okay, so parentheses are kind of a big deal. If you leave out the parentheses, you're going to be wrong. Okay, it's not the same thing. This, that would have been no good without those parentheses. Okay, so let's simplify. When we simplify, I think it's almost always going to be easier to go back to radical form, like we did the last couple of days. So we know that a 1/2 power is a square root. All right, that is a square root. So we're looking at the square root of 36r to the 6th power. You guys got kind of good at these problems the last few days. Square root of 36, well, I know the square root of 36, right? Square root of 36 is 6. And then you're like, well, this root index of 2 goes into 6 3 times evenly with nothing left over. Now, some of you are going to notice, all I did was 6 times 1/2 right there, right, for my power. 6 times 1/2 is 3. But you still have to take the square root of the number. So some of you that are kind of sharp and figure it out and get it, you're going to recognize the shortcut. Okay, if you see that shortcut, that's fine, but it's kind of harder to do with numbers. With the variables, it's not very hard, but with the numbers, it is kind of hard. Does anybody know number 17? Does anybody know what 2/3 of 6 equals? 2/3 of 6 is 4. So keep that in mind. Keep that in mind as like kind of a shortcut. Okay, so look at 17. Look at 17. I've got a denominator 3, so that's my root index. Third root of 343m to the sixth squared. All right. Now, look at the red part. The red part is what we've been doing the last couple of days. The third root of 343, I don't know about you, but I don't know that one. Okay, I don't know that one. So that's where we might want to break it down. All right, 343 is what? What's 7? Well, I don't want the square root. You mean the cube root? Okay. Well, let's just see about this. Okay, so if I wanted to do that on a calculator, 343, I'd have to use an exponent. So to the parentheses 1/3. Okay, you're right. The cube root of 343 is 7. That means 7 times 7 times 7. And that means what I wrote down here in green is not going to work out. Okay, I wrote down divide by 3 because I just kind of thought 343 is divisible by 3, but that actually doesn't work. So let's pretend like you didn't know it was 7. You'd have to somehow figure out that we could divide 343 by 7. Okay, and so this is kind of pointless since we already know what's going to happen. But 343 divided by 7 is 49. 49 divided by 7 is 7. And so that's 7 to the third. All right. So, if you broke it down this long way, you would call this 7 to the third right there. You've got the cube root of 7 to the third m to the sixth. Cube root of 7 to the third is 7, but we already knew that. Cube root of m to the sixth is m squared. Okay. But don't forget about that exponent 2, the numerator. The numerator is this 2, and I don't want you to forget about that because we're still going to have to do that. Okay. So what we're going to have to do is square both of these. Okay, it's definitely going to be m4, yes. But 7 squared is 49. So it's kind of confusing because we're not really multiplying by 2. We're squaring it. But when you square an m squared, you're multiplying the exponents by 2. Okay, so you're multiplying the exponents by 2, but you're squaring the number. So keep that in mind. Your 7m squared times itself, that's what squared means. So it's 7 times 7 is 49, but it's m squared times m squared, which is 4 of them. Okay. Now think about your shortcut. Those of you that knew at the beginning of the problem that 2/3 of 6 was going to be 4, we already kind of knew it was going to be m4, right? But that's kind of how and why. Question? Could you do what? m1/2 squared? Well, I mean, we can because that's kind of what we're dealing with right now. So if you had m1/2 squared, okay, whoa. It's not 1/2 times 1/2. It's 1/2 times 2. You multiply the exponents, okay? You multiply the exponents. 1/2 times 2 is 1. That's going to be m to the first. That's going to be m to the first power, okay? That's going to be m to the first power. All right. That's good. That's good stuff. I like this. I like these problems. I think they're kind of fun. Okay. If you understand that a 1/2 exponent is the same thing as a square root, you might be able to do this one in your head. Anybody think they can do this one in their head? Okay, I'm gonna stop you. I'm gonna stop you. You're getting there. You're getting there, but you bypassed the shortcut. I was wanting you to give me the shortcut. Okay, you're getting there for sure. We know that the 1/2 power is a square root, right? So if that's a square root of 64v squared, square root of 64 is 8, like you said. Square root of v squared is v. That's it. Okay, that's it. Now, yeah, you said it, and then you just kept going. Okay, now check it out. Check it out. What's gonna happen if I put a 3 right there? Yeah, then you'd have to say, well, everything's to the third power, so 8v would be to the third power, and so you'd have 8 to the third, whatever that is, v to the third. I can't do that in my head. 8 to the third, 512. Okay, so that would be 512 v to the third. Okay, now remember that's not the answer to number 19. The answer to number 19 was just 8v, but I just added a what if. Okay, questions? All right, cool. Questions, comments, concerns?